There was a time in the universe when there were no stars yet, when they hadn't formed.
We think that the very first stars in the universe were different than the ones we see around us today. That first generation of stars was likely very massive, very large objects.
What were these first stars really like? On Mount Graham in Arizona, star hunter Dan Stark is searching for clues.
Without a doubt, the formation of the first stars and the growth of the first galaxies was one of the most important events in cosmic history. One of our goals is to be able to witness the first stars turning on.
Dan wants to use the large binocular telescope to investigate the early universe where the first stars may have emerged. With two 8.4-meter mirrors, this 650-ton rotating structure is one of the largest optical telescopes on the planet. But how can he observe stars that existed so far back in time?
One of the great things about astronomy is that we can use our telescopes effectively as a time machine. So because light travels to us at a finite speed, we see the universe not as it is today, but as it was when that light left whatever object we are looking at. What you see here is the Andromeda Galaxy. The Andromeda Galaxy is located 2.5 million light years away. We see this not as it is today, but as it was 2.5 million years ago. But if we want to study the first stars, we need to look at objects that are a great deal further away. So we're not just talking about 2.5 million years ago, we're talking about over 13 billion years ago.
Today, engineers are upgrading the telescope. They are fitting a new detector called Lucy that will help Dan explore the ancient universe. This primal time looked very different to the shining cosmos that we see today. 13.5 billion years ago, the universe was a fog of hydrogen and helium gas. Hidden in this cold darkness, gravity began to clump the gas together. Deep inside, the gas became squeezed in the center until the pressure and heat was so extreme, it triggered nuclear reactions, and a star was born, bathing the cosmos in starlight for the very first time. Dan has measured the light from a mysterious faint smudge, a galaxy called EGS ZS81. It's one of the oldest galaxies ever observed.
This little speck you see here, this galaxy, the light has been traveling for more than 13 billion years. It's located within the first 700 million years of the Big Bang.
But there is something unusual in Dan's data. The stars in this galaxy look different to modern stars like our sun that we see near us today.
We're seeing something that we don't yet understand. It looks like these stars are producing a tremendous amount of energetic radiation.
It appears these ancient stars are not only emitting visible light, but extreme ultraviolet radiation.
You may need very massive or hot stars in order to power the kind of spectral features that we're seeing.
Could these emissions hint at what the first stars in the universe were like? Scientists think they were behemoths. Made from only hydrogen and helium, they grew hundreds of times more massive than the sun. Their unprecedented size sent temperatures soaring, making their surface blaze blue. Burning over 1 million times brighter than the sun, they may have been the brightest stars that ever existed. To find out if the ancient stars Dan has detected could be the first ever formed, he is measuring what they are made of. The only elements to exist after the Big Bang were hydrogen and helium.
Now, if these were truly the first stars, we would expect to just see hydrogen, helium. We wouldn't expect to see any trace of carbon, nitrogen, oxygen, these heavier chemical elements. But we found the evidence for a tremendous amount of carbon already in place at these early times.
Finding carbon instead of only hydrogen and helium means the very first stars must be even further back in time, even closer to the Big Bang itself.
We keep pushing these cosmic frontiers back from 1 billion years to a few, 500 million years to 200 million years after the Big Bang. As we build larger and larger telescopes, we keep looking further and further back, and eventually, ultimately, we'll get back to this first generation of stars, first generation of galaxies, and we'll be able to see these truly primordial objects emerge.
New technology will help astronomers like Dan to one day reveal what the first ever stars were truly like.